Hi everyone, good morning. Welcome to another week of quarantine chemistry. How has your guys' week been? Has it been pretty good? I hope so. This week we're going to talk about walking water. We're going to do 3 density experiments and we're going to talk about triboluminescence. So I'm going to let a few people join us, and please feel free to say hello in the comments. I love saying hi to you guys. Down in the comments below. And remember, if you can't see the video, I know I repeat this every week, but if you can't see the experiments when I flip the screen around, all you have to do is swipe it from left to right, and that'll push those comments to the side. That way you can see. Good morning, Elsie. Good morning, Addison and Ashlyn. Good morning. How are you guys? So our first project that we're going to start on is some walking water. So water doesn't have feet, so we have to give it something that we can let it walk through, and we're going to use some paper towels for that. So the first project that we're going to do, you need 6 glasses, you need 3 food colors, and 6 half sheets of paper towel. So you can use a full piece of paper towel and cut it in half if that's easier. And I'm going to show you how you fold your paper towel, because we have to do that really specifically. Oh, thank you. We're having so much fun doing these projects, so it's wonderful. Thanks, Elsie. So we're going to get it set up, and then by the end of the video, hopefully we'll see what happens with it, and I'll talk about the science behind it at the end of the video once we kind of see what's going on. So I'm going to flip you around, and we're going to get our setup going, okay? So what I've got back here are my 6 glasses. And 3 of them have water and 3 of them don't. I want to make sure you can see this on your screen. So, this has water, this one doesn't, this one has water, this one doesn't, this one has water, this one doesn't. So if you can see, we're repeating. So we want one with water, one without, one with water, one without. And I have about a cup of water in my glasses. That's about how much you want. We don't want to put any less. You can always put more, but you don't want to put any less, okay? So what we're going to do with our paper towel is we've got a half sheet this size, and we're going to fold it. Well, you might have to face me for this. Sorry about the back and forth. I say that every week. So we're going to fold it in half. Good morning, Mary. Hi, Santiago girls. We're going to fold it in half and fold it in half again, and kind of let the folds meet up in the middle. This is hard to do while making sure I'm doing it on camera. And then we're going to fold it over that seam. So remember, this is a half sheet of paper towel. So we folded it inward on itself and then folded it on the seam, and then we're going to fold it in half like this. Okay? And you want to kind of crease that top. Good morning, Aunt Jan. She's watching from Texas. You want to kind of crease that top. That way it's nice and stiff, and we're going to have kind of a teepee. Okay? So you're going to need 6 of these. So you need 6 glasses, 3 with a cup of water, 3 empty, alternating, and 6 of these. Okay? So I'm going to flip you back around. Alright, so what I'm going to use today for my colors are red and blue and yellow, because I want my colors to get nice and mixed up, and I want to see green, and I want to see purple, and I want to see orange. So in my first glass that has water in it, I'm going to take the blue, and I'm going to add quite a few drops of color, because I really want that to mix in. Then, remember, this one's empty, so we're going to go to the next one, and I'm going to do yellow. Add quite a few drops. And then this one's empty, so this one over here is going to get red. Quite a few drops again. And I'm just going to give those a nice swirl, because I hope my hand isn't blocking the camera. Sorry, guys. I want that kind of mixed in. And remember we talked about last week how the water temperature matters with how things mix in. This is room temperature, so it's going to take a little bit for it to mix in. Just give this one a swirl. And like I said, we're going to put this to the side because we want to make sure that it works so you guys can see the experiment fully to completion before we're done with the video. So, what we're going to do now is take our paper towel, remember we TP'd it, and we're going to set it one side in the yellow and one side in the empty jar. Okay? We're going to take our next one. We're going to set it in the empty jar right next to that other one, and then in the blue. Sorry if I'm putting my hand in the way. I have to remember where the camera is. We're taking the next one in the blue and in the empty jar. Then in the empty jar and into the red. Red into the empty jar. And then empty jar into the yellow. So everything is connected. So we are going to push this back. Just shove it to the back. And we're going to let that work. And we'll do a close-up at the end. That way you can see what happens. And like I said, we'll talk about the science behind it. And we're going to go on to, I'm going to flip you back around so you can see me. We're going to go on to a density experiment. So I've got 3 different ones, and we're going to talk about the density of water. Now, like I said, we're just doing these projects with stuff that we have around the house. So the size of the glasses that you use for that and the shape of the glasses that you use for that don't matter. And the same thing for these glasses that we're going to use right now. And with the walking water experiment, if you don't have food coloring, you can use marker, like Crayola washable markers. And you can rub on the end of the paper towel. Just make sure you get it really saturated in the color. And then you can put it in water and then in an empty cup. And then water in an empty cup. And just color the color on the end of the paper towel. And that will work as well. It's just a little easier, a little bit faster to do it with the water and the food coloring, okay? So we're going to talk about the density of water. Now, density is basically the amount of something within a specified area. So if I have this big of an area and I have 2 pens in it, then it's not very dense. But if I have this big of an area and I have 50 pens in it, then it's very dense because everything's packed really tightly together. Now, in cold water molecules, remember, they're moving super slow. They want to stay together. We talked about this last week. So that's going to be more dense. Good morning, Katie. Good morning. And the hot water molecules are bouncing around everywhere because they've got lots of energy. So that's going to be less dense, right? Well, what about something like oil, or what about something like salt water? Well, that's what we're going to test today, okay? So I'm going to flip you back around, and I've got 3 experiments for you. So, our first one that we're going to do is our hot and cold water. So remember, we talked about this last week, and I do have a pan, guys. Can you see this? Let me make sure. Okay, good. I do have a pan because I always practice my experiments before I do them for you. And last night, I had a gigantic spill in my kitchen. So parents, just be forewarned, this could get a little messy when you're flipping water over. So what I'm going to do is, I've got just a laminated card here, so it won't suck up the water. And I'm going to set it on top of my hot water. Now, I've colored my hot water red so that I can tell that it's the hot water. And I'm going to flip it over and try not to let it spill. Now, remember, guys, I'm a chemist. I'm not a magician. I'm not saying I'm the best at this flipping over thing. Like I said, last night we had a big spill. But I'm going to pull it apart. Okay. Now, our water mixed a little bit, but can you see at the top? That was because I let it all spill out. At the top, see how it's really dark red still, and the bottom's still light? Some of my food coloring got mixed, but if you can tell, the hot water is still staying at the top, and the cold water is still at the bottom. Can you see that? The gradient of color, and see I spilt a little bit, so that's why we're doing it in a pan. So our hot water, remember, is less dense, so it wants to stay up top, and our cold water is more dense, so it wants to stay on the bottom because those molecules are not moving around as fast, okay? So let's try a couple others. We're just going to scoot that one to the side and hope it doesn't fall over. Okay, so in this one, we have got some salt water that I've colored yellow and some regular room temperature water that's just white. I'm going to wipe this off real quick. That way we don't get food coloring in the middle of it. Okay. And again, remember, I am a chemist. I'm not a magician. I don't have speedy hands. All right. And my water's leaking out just a little bit, but that's okay. We just want to kind of get them right over top each other. Okay, so I don't know if you can see this very well. Oh yeah, you can. Okay, great. It's showing up on camera. So see, the top is still that nice clear water, and then the bottom is the yellow. That's because salt water has a higher density than just regular water. Now remember, density is all about the amount of molecules within a space. So when we add the salt water to our water, it's making it more dense because it's giving it more molecules to kind of play around with in there, bonded with the water molecules. So it wants to stay on the bottom and the water wants to be on the top, right? Can you see that? I hope so. Okay, so we're gonna scoot the yellow one to the side, again, hoping we don't spill it. Not going to make any promises there. Okay, now our last one is going to be, good morning, Tom. Our last one is going to be oil and water. And again, I've just colored my water. That way you can really see it on camera. You don't have to have food coloring for this. You can just leave it plain white. That's completely up to you. So what we're going to do is flip this oil over the water. Guys, I think this is the most nervous that I've been to do a quarantine chemistry live because this is nerve-wracking to do. And, oh, this is a good one, guys, if I can just get this to work. There, isn't that cool? Okay, so as you can see, that oil is not mixing with the water whatsoever because oil, which you would think would be more dense, is actually less dense than water because the oil has larger molecules within it, and so they have more space. They don't like to pack together. They've got more space, so the oil stays on top of the water. Now, when you think about oil, I think about something heavy, something sticky, and I would think that would be more dense than water, but it's absolutely not. Like I said, it's got those larger molecules, and they stay on top of the water. Okay, so I'm going to flip you back around. So those were our 3 density experiments. So just to reiterate, our cold water is more dense than our hot water. Our salt water is more dense than room temperature water, just with nothing added into it. And our water is more dense than oil. So what would be really cool is if you got a big glass and you did some layers and you could really see the layers in the glass. We did that for a sim project and we did a bunch of layers. We put molasses on the bottom and we did dish soap and we did water and we did oil and we looked at the different layers in there. And that's always a cool project. So this last project that we're going to do is something that you guys are going to have to do at home, okay? But I'm going to explain it to you and I'm going to show you everything that you need to do. But you need to go into a dark room and you need to let your eyes adjust. And we're going to do some triboluminescence. Have you guys ever heard of that word before? Well, tribo means to rub and luminescence is light. So basically what we're going to do is pull some adhesive apart and it's going to emit a blue light. And I'll share a video on the Facebook page, that way you guys can see it and you can see what you're looking for. My husband and I tried to get a video of it and we didn't have the right camera equipment for it. But what you're going to do is, you're going to take just a regular Band-Aid, like this, and this is just like the Walmart brand, if it'll focus on there. It does not have to be Band-Aid brand, just whatever Band-Aid you have. And you're just going to go in a dark room, make sure your eyes are adjusted, and you're going to pull the Band-Aid apart, and you're just going to let that adhesive pull apart, okay? And what you're going to see, as long as your eyes are adjusted, you're in a dark room, is a blue light that comes off of these corners right here. And you want to make sure that you're holding it so that you can see it. So get your setup ready before you go into the room. Good morning, Mom. Good morning. Before you go into the room, you want to have your setup ready. That way you can see it, okay? Now, you can also do this with a self-seal envelope that has the adhesive that you pull off. You can do this with 2 pieces of duct tape that you stick together and then rip them apart. Good morning, Amanda. You can do this with some Scotch tape that you stick together and rip apart. Anything with adhesive that you can rip apart, that's what we want to do. Because when these adhesives are ripped apart, well, I was trying to show you again, but now it's stuck back together. Oh, it's upside down. This is live, guys, I promise. It's completely live. Okay, so when you rip these apart, the adhesives get pulled apart and they get energy. The energy makes those molecules excited. Remember we talked about the hot water last week, how the molecules are super excited, they're moving around. This makes the molecules excited when you add heat to it. And nitrogen molecules from the air, nitrogen is in the air around us, will bond onto those and it'll let out a light. Now you can't see this in regular light. You have to be in the dark to be able to see this. But it's a really cool project. I wish I could have gotten a video of it for you guys. It's so much fun. But you just, Band-Aids, Scotch tape, duct tape, anything with adhesive, just rip it apart and it'll let out that blue light. It looks so cool. And like I said, I'll share a video on the Facebook page, so look for that. And let's look at our walking water. Let's see what's going on with that. I don't know if I can scoot this out of the way without these tumbling. Oh, see? Okay. We'll just let it tumble. All right. So let's see what's happening with our walking water, and let's talk about the science behind it. I made a little bit of a mess. Okay. So, we'll bring these back into the camera frame. Hopefully you guys can see this. Let me check. We'll move it just a little more. There we go. Now you can see it. Okay, so what's happening in here? Can you see the blue going up that? The yellow's going up over here. I don't know if you can see that. And the red's going up over there. I'll give you a close-up once we explain the science. So, I'll flip you back around so we can talk. I feel like this is a little impersonal when you're just looking at that instead of me. But comment below if you just want to look at the experiments instead of this. You can let me know. So, what is happening with the paper towels? Remember we talked about how the paper was made of trees it was a few weeks ago when we did the blooming flowers, and when the paper was rehydrated, it bloomed. That's basically the similar principle that's happening with these paper towels. So the paper towels are made of plants, and plants have capillaries. Now capillaries are little tubes that carry water, they carry nutrients, they carry anything that the plant needs up from the soil to the stems, to the flowers, to the leaves, whatever they need, the water and the nutrients too. It carries them up and then it waters those flowers, it gives the nutrients to them, and this is basically the same idea. It's using the capillaries in the paper towel and it's pulling that water up and it's going to go into our empty jar. So I'm going to flip you around and we're going to go over here so you can see it. So, if you can see, on each side of our blue jar, the blue is going up on the sides. Those capillaries are pulling the water and they're pulling it up. Over here on the red, it's pulled up on both sides. And then over here with the yellow, it's pulled up on both sides. Now this project takes a little bit of time to work, so we'll have to let it work today. And I'll probably have to share a video or a picture with you guys at the end. But the capillaries are going to pull this water up and out of this jar, and it's going to go into this jar. This is going to pull the water up and out of this jar, and it's going to go in this jar. Again, repetitive process. So when this is all done, what we're going to end up with is a purple jar, a green jar, and an orange jar. Good morning, Jenny. How are you? And those capillaries are going to make the water walk over from one jar to the other. And like I said, this process takes a little bit of time because these capillaries are not on the plant anymore. On a regular plant, there's an attraction between the stem and the capillaries, and the force of the molecules comes up with it. These are already ground up plants, so they're going to take a little bit longer. But if you can see, it's already starting to work. And like I said, I'll share a picture with you guys about how it works, and you can share a picture with me about how your projects go, okay? So, remember, let me find my light again. This week we talked about walking water and plant capillaries. We did 3 density experiments with oil and water, hot water and cold water, and salt water and room temperature water. And we did triboluminescence. So if you do any of these projects, please tag me, Kaylee Moreland, or tag the Washington Carnegie Facebook page. That way I can see the projects that you guys are doing. I love seeing you guys do the projects. And I hope you have a great week, and I'll see you next week for more quarantine chemistry. Bye, guys!